So this idea of sequences and series, I don't know if you're aware of the difference between what is a sequence and what is a series. Let's go through some definitions. A sequence, sometimes called a progression as well, it's another name that sometimes gets used, is simply a set of numbers that follows a pattern. Okay, so that's all a sequence is. As opposed to a series is that same set of numbers, but when they're added together. So the series is when they put a plus sign in between each term and we're saying, what do all these add to? That's the technical difference between what is a sequence and what is a series. A, we creatively use as the first term. But otherwise we usually say term n is whichever term, the nth term. Sn is the series. So what do they all add to? What is the sum of those n terms? So an example, there's our general term to work out any particular term. If we wanted to find the fifth term, it's not rocket science, we just a simple substitution question. Oh, it's 27. Is 42 a member of this particular sequence? Oh, well, we just solve general term equals that. Now, it may well have an answer, but n, of course, has to be a positive integer. Because you don't have the half term, and you don't have the negative sixth term, and so on. So in this case, n's the square root of 40. That's not a whole number, so no, that would not be. And that's just something else we've got to get used to, explaining our answers a lot better, rather than just writing things down. Explain why you're doing things. Why am I discounting the square root of 40? Well, it's not an integer, that's why I'm discounting it. So therefore, it's not a term. Now, a recursive formula is another way of writing out a general term. It defines the series though, or the sequence, probably should have been the correct word there, but anyway, defines the series in terms of previous terms. So it designates what the starting term of the pattern is, or sometimes it might be more than one. And then they'll have an expression to say, okay, well, how do you get to the next term using the terms that came before it? So you usually have these two things. So something like that. Here's our sequence. Term n will be term n minus 1 plus 3. So we're simply adding 3 to every term. And this formula will work for whenever n is greater than or equal to 2. So therefore, I need to be told what the first term is. First term is going to be 4. So if the first term is 4, the second term then will be 4 plus 3, which is 7. The third term will be 7 plus 3, which is 10. The fourth term will be 10 plus 3, which is 13. So that's what's called a recursive formula. It's using the terms that came before it. Lucas numbers are very interesting. You've probably heard of Fibonacci numbers. Lucas numbers are very similar. And you'll see it's got the same sort of pattern as a Fibonacci number. To get any particular number, you add the two previous ones together, which is exactly what you do with Fibonacci as well. But in this case, the starting numbers are different. So the first term is 2, so that's the first Lucas number, and the second one is 1. So this pattern starts off with 2 and 1. So to get the third one, we add the two previous ones, so we get 3. To get the fourth one, we add the two previous ones, so we get 4. How many did I say? 5 we're going to find. So now we'll add the next 2, and we get 7, and so on and so on. So that's known as the Lucas series. There are two particular types of patterns we're interested in. We'll look at arithmetic today. So what is an arithmetic sequence? This is one where we're adding a constant amount to every term. Right? And we creatively, for that constant term, we call it the common difference, symbolised with D for difference. So if I wanted to work out the common difference, I could pick two terms. So the second term, subtract the first term. I could get the third term, subtract the second term. In fact, I could get any term I like, subtract the one before it, and it should be the common difference. This now allows me to create a recursive formula, because if I rearrange that, I get that term n is term n minus 1 plus d. And so there's your recursive formula for an arithmetic series. It's probably rare we use that, but there it is in all its glory. Okay, so let's create our general formula. First term is a, second term is a plus d, third term is a plus 2d. Pretty soon we see the pattern that any particular term will be a plus n minus 1, lots of differences. And so there's our general term formula. Of course, it may not be the ones next to each other. This time we're being told the third term and the seventh term, and we want to come up with the formula. Well, the formula is a plus n minus 1d. I just got to work out what a is and what d is. So we can create some simultaneous equations. So the third term would be a plus 2 differences. That's 9. The seventh term would be a plus 6 differences. So basically that means there's 4 differences between these two terms. So I now know the difference is 3. From that, I can go back and work out what a is. So a coincidentally also turns out to be 3. So my formula, a plus n minus 1d, but we can simplify that. Let's expand out the parentheses. And, oh look, it's just multiples of 3, this pattern, 3n. And so then they might say, okay, well now you've worked it out, what's the 100th term? Well, we've just said, well, they're multiples of 3. So 3 times 100, 300. What would be the first one bigger than 500? So what we're saying is, when is the general term bigger than 500? That's what we want to solve. We said the general term was 3n. When's 3n greater than 500? It's not exactly a mind-blowing inequality to solve. 500. But we want a whole number, remember? We want an integer. So we want the first whole number that's bigger than that, which turns out to be 167. The interesting thing here is, what is the answer to this question? It's asking, what is the first term greater than 500? So is the answer, it's term 167, or is the answer 501? You see what I'm saying? Because they're saying, what's the first term? It's the 167th term. Or I'm telling them, so to be on the safe side, I just put both down. It's term 167, which is 501. That's the first one bigger than 500. If you were to simply plot it, now obviously you're not going to get a line, because you're talking about discrete points now. You don't have a y value, if you like, for a half and a third. But if you were to plot them all, then you should get a linear function. Because again, if you look at the general term, you're saying term n, think of that as y, is equal to a plus n minus 1d. Think of n as x, and you've got a linear function there, basically. Y equals some function of x. So when you plot them, you should end up with a straight line. Okay, there's enough chat for me today. So we shall start off with, 1. There's a surprise. We're going to start off with 1a, but not number 1. Ooh, who picked that? Okay.